So we have a problem here where we have a triangle that is definitely not a right triangle. None of these angles are right angles. And we're going to go through the process of finding the coordinates of its orthocenter. The reason why I said it's not a right triangle is because if it's a right triangle, we know that the orthocenter is just at the vertex of the right angle. But if it's not a right triangle, then we have a little bit more of a process that we're going to go through. So the process that we're going to go through is we're going to find the equation of two of the altitudes, because we know the orthocenter is where the altitudes intersect. We're going to find the equation of two of those altitudes, and then we're going to solve that system of equations. So the first thing I'm going to do is I'm going to find the altitude that goes from point A down to segment BC. And first thing I need to do is I need to figure out what the slope of segment BC is. The reason why I need to know that is because then if I find the slope of segment BC, I could use its opposite reciprocal as the slope of the altitude, because we know the altitude will be perpendicular to segment BC, and lines and segments that are perpendicular have opposite reciprocal altitudes. So if I look at segment CB or BC, to get from C to B, I have to go down 2 and then right 12. And so that means it has a slope of -2 over +12. I'm just using the rise over run definition of slope. I went down 2 and over 12 to get from one point to another. Now that simplifies to -1 over 6. Now if that's the slope of segment BC, then the slope of the altitude from A would be its opposite reciprocal, which is going to be +6 over 1, or just +6. From there, what I can do is I can use point slope form. Remember, point slope form is this kind of template where we take any point that's on our line, like 2, 10, right? Because we're writing by line, I mean the line that is the altitude from A. I know that it contains point A, so I can use this as like x1 and y1, and I take that line's slope and put it where m is, and then I would have an equation for the line. So for this line here, we're going to say y minus 10 equals 6 times x minus 2. Again, I just put this point in with x1 and y1. I use this number as the slope, and that gave me this equation. Now I'm going to solve this for y to turn it into the more of the y equals mx plus b format. And the way I solve that for y is first I distribute this 6 into parentheses. So I'll have y minus 10 equals 6x minus 12. And then I just need to add 10 to both sides. So that the y is now all by itself, and I got y equals 6x minus 2. Now, I can actually sketch in the altitude now that I know what the equation for it would be. I know that my altitude from A has a y-intercept at -2. And it also contains point A. So if I connect those 2 points, that should be my altitude line. So I'm going to put that line on my graph here. I'm going to put this line that contains point A, and you can see here if I continued it on, I'll go ahead and make it look a little further, it would cross the y-axis at -2. So that's my altitude from A. I know it's going to be perpendicular to segment B. Now the next thing I'm going to do is I'm going to maybe find the altitude that goes from B across over here to segment AC. I'm just going to repeat this process. First, I'm going to find the slope of segment AC. To get from C over to A, I'm going to have to go up 1, 2, 3, 4, 5, 6, 7, 8. So a rise of 8. And then over 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's up 8 and over 8. So it has a slope of 1. And I guess if I just looked at the line or the segment, I could have seen that. It went up 1 over 1, up 1 over 1. But in any case, that's the slope of segment AC. So the slope of the altitude from point B, right, that comes from point B and goes over here, that would have a slope of the opposite reciprocal of 1. And the opposite reciprocal of 1 is just -1, right? Because this is like 1 over 1, and if I flip that over, it's still just a 1, and I change the sign and make it negative. So my opposite reciprocal of 1 is going to be -1. This line contains the point 6, 0, so that's like my x1, y1 that I'm going to plug into my point slope template. So I'll have y minus 0 equals -1 times x minus 6. And then this one will just turn into, let's see, the y minus 0 is just going to be y. I can distribute the -1 in. I'll have negative x plus 6. So this equation tells me that my altitude has a y-intercept of 6. Go ahead and draw that in. So it's going to have b on it, and it's going to go through 6 on the y-axis. So that altitude looks something like that. Again, makes a right angle. And now my orthocenter is this point right here. That would be the orthocenter, right? Now, if I just eyeball that, it appears that it's close to 1, 5, but maybe a little bit to the right of 1 and a little bit below 5. But that could be just because maybe I didn't draw my picture very accurately. But let's go ahead and solve this system of equations. This is the equation for the kind of this pinkish purple line here. This is the equation for this blue line. If I solve that system of equations, it should be the point where they intersect. So the way I'm going to solve this system is I'm going to take this and set them equal to each other. 6x minus 2 equals -x plus 6. The reason I can do that is because both of those things equal y. They both equal the same thing, so they must equal each other. So let's go ahead and solve this by adding x to both sides. 7x minus 2 equals 6. Then I'll add 2 to both sides, and I'll have 7x equals 8. If I divide by 7 on both sides, the x-coordinate of my orthocenter should be 8 over 7, which is just a little bit more than 1. That's exactly what we thought it might be, just a little bit to the right of 1. Okay, so that orthocenter is 8 over 7, what? Well, to find the y-coordinate, I'm going to take this, and I can either plug it in right there, or I can plug it in right there. This one seems like it might be a little bit easier because I won't have to multiply it by 6. I'll just have to change its sign. So I'm going to come down here and I'm going to say, all right, my y-coordinate is going to be -8 over 7 plus 6. Now I got to add this fraction to 6. So I'm going to say it's -8 over 7 plus 42 over 7. I just converted 6 into a fraction with a denominator of 7 so that I could add it to this fraction. Now I know that my result of this addition is going to have a denominator of 7, and then its numerator is going to be whatever -8 plus 42 is, which is 34. Now 34 over 7, if you were to type 34 divided by 7 in your calculator, you'd see that it's just a little bit less than 5, which is what we had predicted, right? This intersection point looks to be a little bit below 5 on the y-axis. Okay, so that seems to make sense. So I think my orthocenter for this triangle is this point right here located at 8 over 7, 34 over 7.